Hello, our experiment is gravitational acceleration of a car. The physics concepts for motion on a ramp are acceleration, a vector quantity that is defined as the rate at which an object changes its velocity, velocity, a vector quantity that refers to the rate at which an object changes its position, motion, the phenomenon in which an object changes its position with respect to time, gravity, the universal force of attraction acting between all matter, and force, normal force, friction, and weight. Right here in this diagram, you can see how normal force, friction, and weight are acting on the object as it's going down the incline. Here we have the car going down the regular ramp at the 6.096 height and the 11.684 height. And now the car going down the oil ramp at the lower and the taller height. And the dirt ramp with the 6.096 and the 11.684 height. As you can see from this picture taken from the video, we stacked up stones to the height of 11.684 and as well as the 6.096 height. And we had three different ramps, a regular, a dirt, and an oiled ramp. That was cardboard that we set up at a 90-degree angle, and we let the car go down the ramp. We calculated the angle at which the ramp is, the speed going down, the acceleration, and we also calculated the time. Right here, you can see the velocity vector points in the direction of the motion downhill and parallel to the ramp surface. The object has a free fall acceleration straight down. The object also has a vector that is parallel to the incline and a vector that is perpendicular to the incline. We know that acceleration vector of free fall equals the acceleration vector for parallel incline plus the acceleration vector for a perpendicular incline. The magnitude of acceleration vector of free fall is gravity, which is the hypotenuse of the right triangle. The calculations for the height at 6.096 using the hypotenuse of 48.26 gave us a ramp angle of 7.26 degrees, which allowed us to find an acceleration of 1.238 meters per second squared and a velocity of 1.093 meters per second. Therefore, we found the time of 0.883 seconds. The calculations for the 11.684 height using the same hypotenuse found an angle of 14.01 degrees, an acceleration of 2.37 meters per second squared, a velocity of 1.51 meters per second, and a time of 0.637 seconds. The regular cardboard at 6.096 showed an acceleration of 1.207, and then at the 11.684 height showed an acceleration of 2.331. And for the regular ramp, you can see the average times for the shorter height is 0.924 and the taller height is 0.683. The percent error comparing acceleration for the lower height is 2.5% and 3.15% for the taller height. And then again, the percent error for the time was 4.6 for the lower height and 7.2 for the taller height. The oiled cardboard at 6.096 height had an acceleration of 1.136, and at the 11.684 height, an acceleration of 2.258. The average time for the lower height was 1.1 seconds, and for the taller height was 0.75 seconds. The percent error for acceleration was 8.24 for the lower height and 905% for the taller height. The percent error for time was 24.6 for the shorter height and 17.7 for the taller height. The dirt cardboard at the 6.096 height showed an acceleration of 1.053, and at the 11.684 height showed an acceleration of 2.177. The average time for the shorter height was 1.21, and for the taller height was 0.79 seconds. The percent error for acceleration for the lower height was 14.9% and 15.6% for the taller height. For the lower height, for percent error of time was 37.03 and the taller height was 24.02. The objective of this experiment was to better understand how friction and resistance plays a vital role in an object's motion. This was concluded by measuring the friction of various resistance applied on the ramp when performed on a toy car at a slowly increasing speed. In conclusion, the data gathered in this experiment provided an overall understanding of how acceleration is directly impacted by the angle of the ramp when compared against various frictions. Ultimately, this experiment solidified the application of Newton's second law, stating that the acceleration of an object in motion is directly proportional to the net force acting on the object and inversely proportional to the object's mass. The regular cardboard ramp showed largely accurate results with a very small percent discrepancy between theoretical and experimental acceleration. This is because there was no friction on the ramp. The oiled cardboard showed slightly comparable results with a slight percent discrepancy between experimental and theoretical acceleration. This is because there was some slight friction, the oil, added to the ramp. The dirt cardboard ramp showed inaccurate results with a percent discrepancy higher between the experimental and theoretical acceleration. This is because there is a heavier friction, the dirt, added to the ramp. The reason for percent error is due to the fact that friction was added to the cardboards, which would result in some discrepancies when comparing to theoretical and the experimental values, time, and acceleration. Thank you so much for watching.